All right, number 13 has a slant asymptote. I'm just going to talk about the slant asymptote for this one. I'm not going to do all the other work for it. Whenever the degree on the numerator is bigger than the degree on the denominator, then you know there is no horizontal asymptote. There's no horizontal asymptote on this. It is a slant asymptote. So how do you find it? You find it by dividing. So we're going to go x squared plus 0x minus 1. That's the numerator. And we're going to divide it by 2x minus 1. When I do this, let's see. I'm going to have to multiply this by what to give me 1/2 or x to the second power? Oh, dang. 1/2 x, right? Because 1/2 times 2 would be 1, and then x squared, x times x would be x squared. And then I have 1/2 times -1, which would be -1/2 x. Now I'm going to subtract, so I'm changing the signs. This cancels out. Over here I have 1/2 x, and then I get a -1. Okay, what do I have to multiply this by to get this? Or you can say, what is this divided by this? It's up to you. So I get 1/4, so plus 1/4, and that's it. So I get 1/2 x minus 1/4. I subtract by changing the signs. I add that, I get -3/4. That's -1 plus 1/4 is -3/4. Boom. I do have a remainder, but I don't care about it because the remainder is not included for my slant asymptote. That is your slant asymptote. It's y equals 1/2 x plus 1/4. Okay, so let me graph that really fast just to show you guys what it might look like. Remember, it doesn't have to be exact here. 1/4 is kind of right here. And if I go up 1, right 2, it would look like this. Up 1, and then right 2, 1, 2. So there's my new point right here. Up 1, right 2, there's my new point. Up 1, right 2, there's my new point. And then here's your slant asymptote. All right, do we have a vertical asymptote for this diggity dog? Yeah, you take the denominator and set that equal to 0. Whatever makes the function undefined, whatever you get, whatever gives you a 0 for the denominator, it's going to be 1/2. So at 1/2, I'm going to draw a vertical asymptote. So this means my function is going to look like this or this. Oops. And the only way I know for sure is by plugging in points. Actually, look, if we have x-intercepts, that would make it easy because then I would get those. Maybe I would get an x-intercept there. I don't know. But that's how you would do that one. That's how you find a slant asymptote.